Okay, in this problem, we have a car that is accelerated from rest. And it's actually, the car is accelerated from rest because it's being pulled by another car. So there's a rope between them, and there's tension that's provided by that. The tension that's provided by the rope is what creates this graph. So we've got this graph, and it shows the net force on the car by the rope as it travels from 0 to x equals 200 meters. What is the car's speed after traveling this distance? And we want to use the work kinetic energy theorem. So looking at this graph, we can see that our force isn't constant. And so if we're thinking about work, then we need to use the integral. So we're going to say work is equal to the integral of f dx. Now, remember that work is equal to the force and the dot product of delta r, and delta r is the path along which we're moving. And so we can see here that we have this car and it's accelerating along a road. So we're going to say that the direction is the x direction, and so delta r is the x direction, and the force is being applied in the x direction. So this just becomes f delta x, right? And x depends on x. F depends on x, so that's why we need to add the integral. Okay, so we're going to say W is equal to, now if I look at my, at this graph, it's a line, and it's also a line with a negative slope. And so if we figure out the slope, let's say, so we have a slope, so M is equal to our change in Y over the change in X for any graph. And so in this case, it's going to be the change in F over the change in X. And so if we plug that in, we're going to have M is equal to the change in F is 5,000 to 0. So our final, it's going to be 0 minus 5,000, right? X or F final minus F initial over, and our X final is 200 minus 0. So our M, the slope, is going to equal 5,000 over 200. And so that's just 50 over 2. So that's going to be our that's going to be our slope. And so what F is going to be, this line is going to be F is equal to the slope mx. And so F then is going to equal a negative 50 over 2 times x. And where does the negative come from? Well, the slope here, right, is 0. I have 0 minus 5,000, and I have 200 minus 0. So I forgot to add my negatives here. So I'm going to have a negative here and a negative here. And so that's where that negative slope comes from. So I'm going to have a plug that in. I'm going to have a negative 50 over 2x dx. And my x is going from 0 to 200. So it's going to be 0 to 200. So I'm going to pull out the negative 50 over 2. And my integral is just x dx from 0 to 200. And so that is W is equal to negative 50 over 2 and x squared over 2. That's my integral of x dx is x squared over 2. So, and I'm going to evaluate it from 0 to 200. So equals a negative 50 over 4. I've just brought the over 2 here, 2 here, and the 2 here together to make 4. And I'm going to have here 200 squared minus 0 squared. So I've just plugged in my limits here and here into this x squared. So W is equal to, when I put those numbers in my calculator, I get 500,000 Newton meters. And now this is the work of the rope. So there's tension in the rope, and that tension in the rope creates this work. But the actual work done on so that's the work of the rope. And so therefore that's, I take a negative of that to find the work done on my car. So I'm going to use delta E is equal to work. So in order to find the velocity, I need to use the kinetic energy, the work kinetic energy theorem. I'm going to say that this is equal to 1/2 mv delta V squared is equal to work. So I know delta V is equal to V final minus V initial. And I know my V initial is equal to 0, starts from rest. And so I have 1/2 mv final squared is equal to the work. I multiply by 2 and divide by m both sides so that I can cancel these out on the left, and I get V final squared is equal to 2w over m. And so I take the square root of both sides, and I get V final is equal to 2w over m. M square root. Plugging the numbers in, I get 2. The work now is a positive 500,000 Newton meters over 1,500 kilograms, square root. And when I plug those numbers in, I get the final velocity is 26 meters per second. So that's what's happening, is that my the truck that's pulling, or the tow truck that's pulling the car, right, starts out and it pulls with a really big force. As the car gets going, it needs less and less and less force until there's no force, and then the car is traveling at a speed of 26 meters per second. And that's it. So again, the reason that we're able to use a positive work value is because the work that we calculated here, right, is the work that the rope, so the work that the rope was doing, and so that's a negative that the rope was doing, and so that's we say, okay, well, what was done onto the car, and so that's a positive work was done on the car to get it moving.